Now let's look at present values of cash flows that increase at a constant rate. So again, we're trying to figure out what something is worth right now. But in this case, we're making the assumption that those future payments increase at a constant rate. So here's our example. Your daughter's first college tuition payment of $20,000 is due tomorrow, and we'll just think of that as being right now. You anticipate that tuition will increase at 5% per year. How much money must you have today to have enough to pay for 4 years of tuition if you can earn 9% on your money? Well, if we were to just look at the cash flows, we'd say we need $20,000 right now. 1 year from now, at 5% inflation, 1.05 times 20,000 would be 21,000. That's how much we would need at the beginning of next year. And 5% more, or 22,050 at the beginning of the next year, and 23,150,250 at the beginning of the subsequent year. If we discounted them all back to the present, the 20,000 that we need today is just 20,000. This 21,000 would be 19,266, and this would be 18,559, and this one would be 17,887, and when we add them all up, we would need $75,703.08. And you'll notice that that is less than the sum of these, and it's actually, in this case, less than 4 times the first one. The reason is we are earning a higher rate of return at 9% than that inflation rate of 5%. Well, let's see how we might calculate this using the functions on our calculator. And it's going to seem a little strange maybe, so you probably have to follow up on this and back it up and try again and see what happened. So first, let's clear our TVM. So second, clear TVM, second, clear work. And I'm at 4 decimal places because the calculator goes to 4 decimal places, so it goes to many more, of course. And you can take the steps to go through to change the number of decimals. But it's important that you take this step up here. Second, begin, second, set, clear entry. So second, begin, second, set, clear. And now we show BGN up at the top, and we have to for this type of problem. So our payments are 20,000, 21,000, 22,050, and 23,152.50. However, we are going to trick the calculator. We're going to trick the calculator into thinking that this is an annuity due. It isn't an annuity due because the payments aren't equal. But when we use the adjustment of rates for what we might call a real rate of return, like we did in the previous video, we can treat this as if it were an annuity, as long as these amounts are growing at a constant percentage. So we're going to put 20,000, change signs, as our payment. There are 4 periods, 4, N. Now we put in the payment, we put in the N, we're trying to calculate the present value, so what we need now is a rate. Well, what is our rate? Well, we're going to use that previous video calculation to calculate a rate. 1.09, which is 1 plus the 9% rate of return, divided by 1.05, which is that 5% is our growth rate, equals 1.0381. Then we can subtract 1 and multiply by 100. And that's 3.8095. Now we're going to put that in as our rate. So now we have our payments, we have our N, and we have our rate. And let's just compute the present value. And it's $75,703.08. So that's a weird way of doing things maybe, but it's the way that works. And it's a way that I would encourage you to get used to. Now, what if the payment is not at the beginning of the year? What if it's if the first payment doesn't occur till the end of the first year? And if it's still $20,000? Well, you might think that you would set this to end of period payments, but you don't. You still solve it as a beginning of period payment problem. The adjustment that you make is after you get your answer here. At that point, then you say divide by 1.09. So we're going to say divide by 1.09 equals 69,452.36. Now let's see if this makes sense. We have a present value now which is less than the present value that we had before. Well, that does make sense because the payments are farther into the future. And the reason that we could not just set this to end of period payments is because there would the combination of the inflation rate and real rate would not have been in effect in that very first year. We would be discounting the 20,000 one period at 9%, but there would be no increase from time 0 to time 1 of 5%. So we can't just set it for end of period payments. We have to keep it at beginning of period payments and then adjust at the end by dividing not by 1 plus the real rate, but by 1 plus the nominal rate. And as it says here, you might want to go ahead and return to end of period payments. And to do that, we say second begin, second set, clear entry, and we're back to end of period payments.